Hello, welcome to thedeciphers.org. My name is Cordelia Kataria and I am a 9-year-old computing explorer and problem solver. So today we're going to do stuff about the binomial expansion.
That's right, so I'm Isaac. I'm helping out with the Deciphers.org and delivering these free A-level revision sessions. So exams are coming closer and closer, so each session we'll be looking at a different topic, and as Cordelia said, today we're looking at the binomial expansion and the binomial theorem. And how can people interact with the session, Cordelia?
They can interact by typing something in the chat if they have an idea about how to solve a problem or something like that.
Great, yeah, if you have any questions, put them in the chat. If you think of a different way you can solve the problem, then yeah, we'll be interested to hear your ideas. Brilliant. And also, if you have any topics that you want us to cover in upcoming sessions, drop that in the chat as well, and we'll plan a session, our next session, on whatever people want to get covered. Okay, so the way these sessions work, we do a quick sort of overview, sort of like cheat sheet of the topic, and then we have 3 or 4 questions to do that Cordelia will work through, and I'll offer some hints along the way and sort of talk about what an examiner is expected to see in answering these exam questions, and as well as sort of what formulas are given in exams, which ones aren't, which ones you need to know. So all of that along the way to help you with your A-level revision. So first thing we're going to talk about the binomial expansion for natural powers. Now, Cordelia, what do I mean by a natural power?
So natural power is basically, a natural number is a number that's is basically a positive integer, and so a natural power is basically a number to the power of a natural number.
Yeah, so a natural number is a counting number, so a positive integer, 1, 2, 3, 4. So in year 1 of your A levels, AS levels, you do binomial expansion where the power is a natural number only. Okay, and the rule is the binomial expansion is a rule that allows us to expand brackets with these natural powers. So you can use this NR notation, which we call N choose R, sometimes written like this, and that's what the number on your calculator, the button on your calculator will look like, this N choose R. So that's the way we say it, because it's how many ways, if with N objects, how many ways are there of choosing R of them. So that's why it's N choose R, and it links with Pascal's triangle, okay, to work out the coefficient in the binomial expansion. So for example, in a plus b to the 5, which would be a plus b times a plus b times a plus b times a plus b times a plus b, if we wanted to find the b cubed terms, well, you can choose multiples of b from 3 different brackets out of the 5. So it would be 5 choose 3. There's 5 brackets to choose from, and you're choosing 3 of them. So we have this 5 choose 3, and we have b cubed, but also a squared, because you're choosing 2 of the a terms, because if you're choosing b from 3 of the brackets, you must be choosing a from the other 2. So these 2 powers here, for natural powers, should always add up to what we're raising it to, so in this case, to the 5. So our general rule for the binomial expansion is the natural powers is if it's a plus b to the power of n, then you have a to the n. Technically you could have n choose 0 there, but it's a to the n plus n choose 1, which is just n, a to the n minus 1b plus n choose 2, a to the n minus 2b squared, and you see the pattern coming that the powers of a are decreasing whilst the powers of b are increasing, and they always add up to n. Okay, and this formula for n choose r is given in the formula book as well. So it's n factorial over r factorial times n minus r factorial. So that's the stuff you would have seen in year 1. In year 2, you look at rational powers. Okay, and what's a rational power, Cordelia?
Well, it's basically, well, a rational number is basically a fraction. So a rational power is basically a number to power of a fraction.
Brilliant. So any number that can be written as a fraction is a rational number. So the difference between the year 1 and the year 2 content, year 12 and year 13 content, is year 1 you just have positive integers, 1, 2, 3, 4. In year 2 you look at what happens if it's a fractional power and what happens if it's a negative power as well. So or a negative fraction you could get as well. Okay, so we might want to expand a plus bx to the n when n is no longer a positive integer, so no longer a natural number. We use another form of the binomial expansion, and it's this 1 plus x to the n. Okay, and that's the form that's given to us in the formula book. And it looks like a complicated formula, but there's a really nice pattern to it that you spot. So you start off with 1 every time, and then you have nx, so just the power that you've got times by x over 1 factorial. 1 factorial is always 1. And then the numerator, you basically times it by 1 less than the previous term each time. So you have nx, then you have n times n minus 1x, and then the denominator is the next factorial, so 2 factorial. Then the next term, and obviously you've got this x squared term as well. So the powers of x increase. Okay, it's an infinite series. It's called a binomial series, infinite binomial series, and it goes on forever and ever. So the next term will be n times 1 less than n times 2 less than n over 3 factorial, but we've also got the x cubed term as well. Okay, but because it's a infinite series, we might think, well, why does this not go to infinity? If we've got an infinite series, how come 1 plus x to the n surely is going to be infinite if it's an infinite series? But the problem is this expansion is only valid when our higher powers of x get smaller, but it's only valid when our modulus of x is less than 1. What's another way we could say our modulus of x is less than 1, Cordelia? What's another way you could say that?
It's because, so another way you could say that is x is between minus 1 and 1.
Yeah, brilliant. So another way we could say that is between negative 1 and 1. Yeah, brilliant. So this is our formula that we're given. If we had, so you notice it's 1 plus x to the n. If we wanted 1 plus bx to the n, then we just replace x with bx in the formula. It's quite straightforward, and we'll do an example of that. If we wanted to expand a plus bx to the n, so what's the difference here, Cordelia, between 1 plus bx to the n and a plus bx to the n?
So the difference is that for the constant before the bx is 1 on 1 plus bx to the power of n, but the constant is a on the second term, and so basically what you need to do is divide by factor out a to power of n before we do the thingy.
Brilliant, yeah. So we always want to factorise. We're factorising a out, but remember we're going to factorise out a to the power of n because in here we do have a to the n in there. So we're going to factorise out a to the n so that we get it into the form 1 plus, so that this formula is only valid for 1 plus bx to the n. Okay, yeah, brilliant. And then if we did have a plus bx to the n, where n is a rational number, so negative or fraction, it's valid only where the modulus of x is less than the modulus of a over b. Brilliant. Okay, so those are our notes. Now we're going to go through a few examples. We'll look at some examples with a natural number, so one you might see in an AS paper, but could still come up in an A2 paper as well, and then one with rational powers, the harder ones that are more common, more likely to come up in those A2 papers. So we've got a few of those as well, and tying in with some other topics that we've covered in previous weeks. So should we go to the first question?
Yeah, so let's go to question 1. Okay, so for part 8 it says find the first 3 terms in ascending powers of x of the binomial expansion of 2 minus x divided by 16 to the power of 9, giving each term in its simplest form. f of x is a plus b out.
Should we just do part A and then we'll talk about part B once we've done part A, yeah?
Okay, so
the first 3 terms, it's quite common that in an exam they don't ask for the full expansion. They just ask for the first 3 terms, or up to and including the x cubed term or the x to the 4 term. So you'll see the different style of exam questions, but yeah, it's very unlikely they ask for the full expansion.
So first we need to factor out 2 to the power of 9, so then it would be 2 to the power of 9 times by 1 minus x divided by 32 to the power of 9. So then what we need to do is just expand it, so 2 to the power of 9 times, so there was 1 plus nx, it's 9x and 32, plus n.
Or you might want to just scroll down a little bit or move where you're writing, because our faces are covering it, so the people watching won't be able to see.
Okay, so then just going to zoom out a bit. Still not. That didn't work. Anyway, let's just
Maybe just do it underneath rather than to the right.
There's some sort of problem and every time I change something it just goes back to normal. When I zoom out it just stays like that for some reason. So I'll just go like that. So
Yes.
So 2 to the power of 9 times like 1 plus 9x in 32. Okay, and then plus n times, there was that times n minus 1 times.
Well, so with this one, remember that it's a natural power of n. So what?
So all we have to do is 9c2 times by that. So that's so that is a second. Forgot to bring my calculator, I guess. So I'll just stop straight.
I'll do my calculator here if you need me. What calculation do you need me to do?
9 choose 2.
9 choose 2. So obviously you could use the formula that's given in it's 36. It's
So 36.
9 times 8 divided by 2. That is the calculation to get that.
So that's squared. Right, and that's the same as 2 to the power of 9 times 1 1 plus 9x is 32 plus, and then well, 32 squared is
32 squared.
That's 1024.
24.
So that's 36. If we times that by 36, then we'll just do 36 times 1024. X squared.
Well, it'll be 36 over 1024.
So I can't rub it out. Just cross that. I'm just gonna. There we go. Right, so then what you can do is 36 divided by 1024 x squared, and right, and I'm pretty sure that can simplify to
36 over 1024 times by 2 to the 9. 2 to the 9 is 512, gives us 18 when you expand it.
Right, so, so it was 2 to the 4.
So so 36 over 1024 is 9 over 256.
Okay. So I think I've got my calculator back now. 2 to 9 9 16. Okay, so that's 144. 2 plus 9 plus. Oops. That's 144 plus. Okay, so times 2 to the power of 9, 18. X squared and x, so 2 to the power of 9 is 512. So
Yeah. Remember, in your brackets though, your x over 16, look carefully at it again, look at the original question, because you've missed something else.
Find first printers sending powers of X function of that. Right, giving each time its simplest form. Not sure I've missed out.
So your final answer is what, 512 plus 144x plus 18x squared?
Yeah.
Okay, it's your middle term that's not quite right.
Right.
So
one second.
you've made a mistake in this bit of working out here. The second line of working out, where you factorise that 2 to the 9, and I'm going to talk about that in a second anyway. But you've changed your what was originally minus x over 16, you've changed it to plus.
And yes, all of that just changes to minus, 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 and minus. Okay.
Okay, that's right there. So I'm going to quickly, because what you've done there, Katilli, you've factorised out 2 to the 9, which is a required step when n, our power, is a non-positive integer, so whether it's negative or a fraction. But in this case, you didn't need to do that, because the binomial expansion, using sort of the choose method, the Pascal triangle method, it works for when it's a plus bx, so not when and a is not 1. So what you could have done, so if you just scroll down a bit so people can see it, I'm going to just do a little bit working out of sort of an easier way. We could have done that question. So we've got 2 minus x over 16 to the 9. So you start off with, and I think it's a really good way of setting this out is to write it all down vertically. So you have 9 choose 0, 2 to the 9, and then minus x over 16 to the 0, 9 choose 1 times 2 to the 8 times minus x over 16 to the 1, 9 choose 2 times 2 to the 7 times minus x over 16 squared. Okay, 9 choose 0 is 1, 2 to the 9 is 512, and minus x over 16 to the 0 is 1, so this becomes just 2 to the 9, which is 512. So these should be pluses here, not equals. Then we've got 9 choose 1, which is 9, times 2 to the 8 is 256, times minus x over 16 to the 1, which stays as minus x over 16, is our minus 144, and we could just put that straight in our calculator, as it is 9 choose 1. And then our third term is 9 choose 2 times, which we've said is 36, times 2 to the 7, which is 128, times minus x over 16 squared becomes positive, and that will simplify to 18 x squared. And then we do have more terms, and you can carry on this method if we need to find more terms, but we end up with our same answer, but we didn't need to take out that 2 to the 9, we didn't need to do any factorising. It just makes it a little bit easier, and I think setting it out vertically going downwards just gives us a nice clear way. We can see that it's easy to spot the pattern, isn't it? You can see our powers of 2 are decreasing, our powers of minus x over 16 are increasing, and we get a nice simplified answer at the end. So with our ones where it's n is a natural number, then this is a nice easy way to do it. It doesn't take long at all. Okay. So then the next part of the question says that f of x is a plus bx. So I'll write it down so we can see f of x equals a plus bx times by our 2 minus x over 16 to the 9. A and b are constants, given the first 2 terms in ascending powers of x in the series expansion are 128x. So this is equal to 128 plus 36x plus dot dot dot. We want to find the value of a and the value of b.
So we worked out that 2 minus x power 16 to the power of 9, that was 512 minus 144x plus 18x squared. So 512 minus minus 144x plus something x squared plus 18x squared.
Yeah. So we're using our part A spot on.
8, that times a plus bx is 128 plus 36x plus dot dot dot. So guess what we need to do is just so yes, we can just all we need to do is focused on these two terms. So all we need to calculate is just that times a plus bx. So yes, that would be next. So 512 times a is 512a minus 18. So 512 times bx is 512bx, and then minus 144xa is minus 144ax, and then I'm pretty sure that's all we need actually, because we have only two of those terms.
Yeah, we don't need anything with that in x squared, so we can ignore the 144x times bx. That will give us a term in x squared.
And we can also ignore the 18x squared too, because that's x squared or x cubed. And this need to do is 5. Which one did it say to calculate first?
Part B was to work out a first.
Okay, so 512a is, so if we compare the coefficients, we get 512a is 128.
Good, so yeah, we're equating coefficients, spot on. The 512a is 128.
So that's what, a quarter.
Brilliant, a is a quarter.
Okay, so now we can do part C.
Good.
Okay, so quarter times 512, we already calculated, that was 128. Okay, and that plus 512b x minus.
Why have you got? Oh, sorry, yeah, carry on.
Minus 144 x is 36x plus 128. That's 1, 2. So all we need is 512b minus 144a is 36.
Good, so now we're equating our coefficients of x. Yeah, brilliant.
Okay, so we already worked out that a was a quarter, so I guess that's 36. So 512b minus 36 is 36. 512b is 72. So b is 512 divided by 72 is 64.9. Yes.
Cool, are you sure? It doesn't look like it's going to be a top heavy fraction if 512b equals 72.
Yeah, so it's the other way around.
Yeah, 72 divided by 512.
9 in 64.
Brilliant, so our a was a quarter and our b was 9 in 64. Brilliant. Well done. Okay, so remember that was one that could have been in an AS paper, and could well be an A2 paper as well, because our power is a natural number. So now we're going to look at ones where it's not a natural number, it's a rational number, a non-positive integer. Or it could not be an integer. So are we on the next question now?
No, just 1 second. Can't scroll down. I think I know.
That's the challenge question. That one. Yeah, there we go, that's right. 1 plus 8x to the half, yeah. Okay, so find the first 4 terms in ascending powers of x of the binomial expansion of 1 plus 8x to the power of a half, given each term in its simplest form. And then explain how you can use x equals 1 over 32 in the expansion to find an approximation for root 5, which we don't need to carry out that calculation.
Okay, so part A. So 1 plus 8x to the power of a half. Okay, then that would be
So when you're doing it, because I explain the pattern that you're using, you know, the formula's in the formula book, but I think it's a lot easier to think about the pattern that you're doing each time for each term that you're working out. So
for each, I guess for each time we do we multiply by n, but just n minus something, and then divided by. So basically, you do n times n minus 1 times n minus 2, and we do that a lot, and then divide by the number, the term number factorial, and then
yeah, the factorial matches the power that you've got, so that's a good way of remembering which factorial you're doing. So technically, what's always the first term? If it's 1 plus bx, the first term is always.
If it's 1 plus bx, the first term is always 1.
Brilliant, so that's why that one done.
1, and then the next time that's just the number times x divided by, and 1 factorial is just 1. So
yeah, so the first time we could actually think of it as to a 0 factorial if it helps, because that's our power of 8x in this case. Is 0 is 8x, so 0 is just 1, and 0 factorial is 1, which is confusing to think why it's 1, but 0 factorial is 1.
And the term after that?
Yeah, I think it's good to show you working out, so just rather than just writing 4x, you know, show that as a half plus 8x, I think is, so a half times 8x. Just so we can really see the pattern that happens with these binomial expansion questions. Good to go.
Then plus a half times by in first 4 times, so half times a half minus 1.
Good.
Divided by 2.
Yeah, and that's 2 factorial, which is 2, but yeah, divided by 2. Yeah.
By times by 8x squared.
Brilliant, and well done remembering those brackets around 8x squared, that always catches people out. They just square the x and forget to square the 8.
Yeah, so a half times a half minus 1 times a half minus 2 divided by 3 factorial times 8x cubed.
Brilliant.
So that's the same as 1 plus 4x plus, so a half times minus half, that's minus a quarter, and divided by 2, that's actually minus an eighth, minus a eighth times 64, that's minus 8 and squared.
Brilliant.
And then times a half times is a half minus 1 times a half minus 2, right, and then divided by 6 times 8 cubed, it's 32x.
Brilliant.
32x cubed, right, and it gives that.
That's it.
Yep.
Yeah, so if this was asking for the first 4 terms, it might say, the terms up to and including x cubed. But yeah, you've done exactly right. Well done. So hopefully that helps the watchers, those people watching, see the pattern as well by showing working out like that. So these questions, once you've done it 3 or 4 times, they're really easy. It's just plugging the numbers into the pattern. So part B questions can be a little bit more interesting. It might get a bit harder, and they're not always as straightforward as you think, but this is quite an interesting one. So explain how you could use x equals 1 over 32 in the expansion to find an approximation for root 5, which we don't need to carry out the calculation.
Okay, so then, so to find an approximation for root 5, so yes, 1 plus 8x has to be something like, so if we sub in x is 32,
Good, yeah.
1 plus 8 and 32, which is, okay, so that's 40 and 32, and that simplifies to 5 and 4. So if you sub in 1 over 32, then you get root of 5 and 4.
Yeah. Which is?
So that's root 5 and root 4, which is root 5 in 2. So
Brilliant.
we would sub in 1 in 32 and
Into what? Sub 1 in 32 into what?
and also the reason why we can't do 5 already is because as of x has to be less than 1/8. So
Good, yeah, x has to be 1/8, yeah. That's right.
So if we sub in 1 in 32 into expansion.
Yeah, so that's important that you're explaining, and the marks will expect you to explain that you're substituting 1 in 32 into the 1 plus 4x minus 8x squared plus 32x cubed, yeah, so into your expansion, and then do what?
And then multiply by 2.
Fantastic, yeah. Yeah, so a lot of those questions are a simple case of just substituting the number in, and that will give you your approximation. But in this case, and it's coming up more and more in recent exams, where you have to substitute in it and then manipulate it. So it's an interesting question.
Yeah.
Yeah, you're spot on. Well done.
Yes. There we go. Question
Okay.
3.
Question 3. So I said that we'd use combined binomial expansion with a different topic, and this is one which we covered in a previous video not that long ago. So if you need to revise partial fractions, then you can go back and watch one of our previous workshops where we worked on partial fractions. And I said in that video, that partial fractions comes up a lot with binomial expansion, and this is a perfect example of that. So an 11-mark question, part B worth 7 marks altogether. The first part, so we're given a function 50x squared plus 38x plus 9 over 5x plus 2 squared plus 1 times by 1 minus 2x. X isn't minus 2/5 or a half because then our denominators will be 0. Given that fx can be expressed in the form a over 5x plus 2 plus b over 5x plus 2 squared, because you've got that repeated root on the denominator, so you have to include 5x plus 2 and 5x plus 2 squared, plus c over 1 minus 2x. A, b and c are constants. Find the values of b and c and the value of c and show that a equals 0. And this was actually a question that we did in our partial fractions lesson. So we can we'll do it again. But if you had watched that video, you've seen that we've oh no, it's not actually one, it is different. Sorry, ignore me. It is a different question. Very similar to one that we did.
Okay, so for part A, that fell on the screen. Okay, it does. So then what we can do is, so it's just partial. So we have to use partial fractions. So it's a times 5x plus 2 times 1 minus 2. So we're converting each fraction to have the same denominator. So 2 squared is 1 minus 2x. And then plus b times 5x, not 5x plus 2, by 1 minus 2x, whereby 5x plus 2 squared times 1 minus 2x, plus then it's c times 5x plus 2 squared divided by 5x plus 2 squared 1 minus 2 1 minus 2x. So then, yes, it's, I think, so if that's the same as 50x squared plus 38x plus 9 is 5x plus 2 times 1 minus 2x.
Good. Yeah, so essentially what you're doing, just for the watchers, you're putting those fractions, going through the method you would go through as if you were adding those fractions. So finding the common denominator, which would be 5x plus 2 squared times 1 minus 2x, timesing the fractions by the relevant factor, and then simplifying and then equating the numerators only, because then the denominators are the same. So you've got your 50x squared plus 38x plus 9 times by the sum of the numerators from your three fractions that you've sort of unsimplified so that you can add them together.
Yeah. So then that's that plus b times 1 minus 2x, and then plus c times 5x plus 2 squared. So then that is it. So what we have to do is to sub in some values of x. So
Yeah.
and then that makes which will make them 0. So then we can work it out. So yes, first we can do 1 minus 2x. It's in A and B. So then let's do 1 minus 2x is 0. 1 is 2x. X is half.
Good. So if you substitute x equals a half, all the 1 minus 2x is go to 0, and we're left with just our c times 5x plus 2 squared on the right hand side. So yeah, that's good. So you can do the substitution. You can do the substitution on your calculator and just.
So c times by 5. Right. C times by 5 and 2 plus 2 squared equals to 50, and by half squared it equals to, that's 25 over 2 plus 38, that's 19 x and then 11 and then plus 9 and so I guess 9. So 81 and 4, 81c and 4 is 25 and 2 times 8, not x squared, not x, and 2 plus 9. 8. So I guess that would be 61 and 2. So C is
So shouldn't it be? Is that an 81 and 2? Should be 81 and 2, shouldn't it?
That's 61 and 2.
Are you sure? Then you use your calculator, just double check. Yeah, make the most of your answer button on your calculator or storing it for x. Because you're going to use that formula quite a lot.
9, it's 19. So if that's 28. So that's 28 times 25 and 2. That's 81 and 2. Then C.
Yeah, so 81 and 4, C equals 81 and 2, so C is...
C
yeah.
is 2.
Yeah, remember, majority of time it's going to be an integer, or at least If it's not an integer, it's probably a nice rational number like a half or something. So if you get something that looks pretty horrible, then go back and check that you've done it right. Not to say that it's always an integer or a nice number, but majority of the time it is. So always just double check.
And then we can work out b by just subbing in minus 2/5.
Yeah, so if you sub minus 2/5 into the left hand side, the 50x squared plus 38x plus 9, I'll sub it into the right hand side.
Alright, so then that's 50 times by 50. So 50x squared plus 38 plus 9. Okay, and that is 161.5, I think.
You sure? So when x is minus 2/5 because we're making the a and c times 0.
I did positive 2/5. Okay, so that's 9 and 5. So x is minus 2/5. And it's 9 and 5 is 1, and then it's 1 minus 2. Then 1 minus 2x is 1 minus 2 times. That is also 9/5, so 9/5 b. So b is 1.
Are you sure? You're right that b is 1. But let's just check. If I just check by substituting them in. Yeah, you're right. You're spot on. Yeah, b is 1. Getting a bit of background noise, Cordelia. Do you know what that might be?
No. I'm just going to write this one. Just 1 second, just going to change this. Okay, is that better?
Yeah, I think that's a bit better. Yeah.
Right. So that's if yes.
Okay, yeah, so C is 2, B is 1.
Okay, so then for part I, for part 2.
We need to show that A is 0.
Yeah, so we can just sub that in, so 2 times 5x plus 2 times 1 minus 2x. Right, so then
2 times that.
Yeah, because
It's A times that, isn't it?
yeah, so then A times that plus B times 1 minus 2x. B is 1, so I'm not writing B. And
Good.
C is 2, so plus 2 times 5x plus 2 squared is just equals that.
Good. And what's going to be a good number to substitute in?
And we can sub in 0 because what that is going to do is gonna leave us with just the last number, which is 9. So anything to do with x just goes to 0. So it's easier to calculate it.
Brilliant. So we end up with, if we stick x equals 0, then we end up with 9 from the 50x squared plus 38x plus 9. That becomes 9.
Yeah,
good.
So 9 is, and then a times 2a, not 2a, yes 2a, and then that plus 1.
Good.
Okay, then plus it's 8.
Good, yeah. So it becomes 2 squared times 2, so 8, yeah.
So 9 is 2a plus 9. So then a is 0. 2a is 0, so then a is 0.
Fantastic, okay. So that's a big reminder of partial fractions, yeah, well done. So we have then our f of x is b, which is 1 over y of x plus 2 squared, plus c, which is 2 over 1 minus 2x, and we want to use polynomial expansion to show that instead of powers of x, f of x can be written as p plus qx plus rx squared. Okay, so first 3 terms time up until nx squared. So, and we want to simplify p, q, and r.
Okay, so then what we can do is just, so f of x is, we can rewrite that as 5x plus 2 to the power of minus 2.
Good.
Plus 2 times 1 minus 2x to the power of minus 1.
Good.
And then so then we can just use so that's the same as, so 2 to the power of negative 2, so a quarter times 5x into.
Yeah, maybe write it as 1 plus. Yeah, keep it to, well, you might find it just to be consistent, because our formula is always 1 plus x, 1 plus bx or whatever.
Yeah, and that times minus.
And just explain where the quarters come from?
Where the what comes from?
The quarter.
The quarter that comes from the quarter comes from 2 to the power of minus 2, because you need to factor that out.
Yeah, so we're factoring out the 2, but remember it's 2 to the minus 2, which is a quarter. Yeah, well done. So let's just expand that bit first before we think about the other fraction, the other term. So let's expand that bit first.
Okay, so then let's.
It's best to just break it down into each part separately, then put it together at the end, otherwise the working out can become a bit messy.
Yeah, so then like 1 plus, and then by 1 plus, and then minus 1 minus 5x.
Yep, so 5 over 2 times negative 2, nx.
Okay, so that simplifies the 5x. And then you do this plus, and then minus 2 times minus 3 divided by 2 by 5x into squared. Right, and need to expand it to 8, so just up to the square 10. Okay, so then it's that, which is a quarter minus 5 in 4x.
Good.
And plus 3 plus 3 times 25 in 4. That's 75 in 4x squared.
Good. Yes, that's spot on. 75 in what, sorry?
75 in 4x squared.
Oh, don't forget to square the 2 on the bottom.
Yeah, so that's 8.
So you've got 5x over 2 squared becomes 8, and then don't forget you've got the quarter as well.
Which quarter?
At the front of the brackets.
And that's actually 32.
Oh, but it cancels out with one of the 2 on the top. It's not 32 either. So you've got the negative 2 and the 2 on the fraction, they cancel out. And you've got the 2 in the 5x over 2 squared, so 2 squared is 4 times by the quarter. You're going to get 16 on the denominator.
Yeah. So then 2 times 1 minus 2x, to power of minus 1. That is, and then that's 2 times, and then 1 plus 2x, and plus minus 1 times minus 2 divided by, and divided by 2, and then that times my 4x. That is 4x squared.
Yeah, you're right, it is 4x squared again. But make sure if you're watching this, you're being careful with your negative numbers, because it is minus 2 all squared, so it does become positive 4x squared. But if we have to carry this on, then there might be more negatives to watch out for. But
yeah, so
you're right, well done.
then that would be 2 plus 4x, and and then all of this just goes out, and then it's 2 times 4x squared, that's 8x squared.
Brilliant.
Okay, so all we need to do then is just add those 2 together, and we get, so that's
Yep, so we're adding this one and this one together out, yeah.
2 and quarter, that's 9 quarter, that's 9 in 4,
Good.
then 4 plus 4 minus 5, that's 11 in 4,
Good.
4x, and then 8 minus 75 and 16, that's 53 and 16, wait, plus not minus, and that's 203 and 16.
203 and 16, yeah, exactly. Yeah.
X squared. So,
Excellent.
and the
And
question,
the last part of the question is state the values, the range of values of x for which this expansion is valid.
yeah, so 1 second, 203 and 16. Okay, so then over C, and for the 1 minus 2x, so
Yep.
add the absolute of x is less than, so absolute of minus 2x is less than 1, so of x is less than negative, less than positive a half.
Good, yeah. Remember that the modulus of the absolute values gets rid of any negatives, yeah. So modulus of x is less than a half makes the 1 minus 2x to the negative 1 valid.
Yeah. So then, and what we need to do after that is just so we have to work out the one for 5x plus 2, and just so abs of 5 and 2x is less than 1, so abs of x is less than, and that's 2/5. So 2/5 is 1, so is a more stricter one, so minus 2/5 is less than x less than 2/5.
Brilliant. Yeah. So you look for the strictest one because it has the modulus of x has to be less than a half and less than 2/5. But because 2/5 is less than a half, anything less than 2/2, 2/5 is less than a half anyway. So we take that one. Brilliant. Good. So let's move on to the challenge question. Now the challenge question this session is not quite as difficult as challenge questions previously. Normally, our challenge question is something that's sort of a little bit beyond what you'd expect to see in the A level, but because binomial expansion sort of only goes so far, it's hard to get it harder than a question you see in the A level, really. So it's just another sort of question that we might expect to see. But that may be a little bit trickier, but hopefully one that won't take too long.
Okay, so then expand expand 2 plus 3x to the power of minus 2 up to including x cubed. Whoops. So in. Right, so for part A, we have to rub that. For part A, we have to just expand that, so 2 to the power of minus 2 is a quarter. It's 1 plus 3x into 2 to the power of minus 2. Okay, and then that is 1/4 times by 1 plus then 3x 2 then that's 6/5 x, and then plus minus 2 and minus 3 into And then that times by 3 and 2x squared. 3 into x. No, what squared? Then
the second term there, Cordelia, it looks like you've written 6/5. Is that right? Or is it just? I don't know where the fifths would come from.
So it's going to
The term in x. What should it be?
minus 3x minus 3. So that is just a quarter minus 3/4 x and plus 3 times plus 9 x squared. And I think 3, 2 squared times minus 2 minus 3 divided by 2 and then divided by 4. It's 27 and 16. X squared.
27 and 16, yes, spot on, well done.
Okay, then just need one more time, I guess. Then minus plus minus 2 times minus 3 is minus 4 and 2. And then times 3 and 2 cubed. So then that is
Minus 2 times minus 3 times minus 4 over 3 factorial times 3 over 2 cubed, yeah.
So that's minus 81 and 2x cubed. So for part B.
You times that by a quarter as well.
Oh yeah, so it's 81 and 8. So far.
Let's just check. I'm going to check that one. So minus 2 times minus 3 times minus 4. Yeah, minus 24. Divided by 6. Minus 4. Times by 27 over 8. It's minus 27 over 2. And then times by a quarter. I think it should be 27 over 8. Not 81 over 8.
Okay. So
Maybe you times by an extra 3 somewhere. Okay, good. Yeah, so that's right now. So a quarter minus 3/4 x plus 27 over 16 x squared minus 27 over 8 x cubed. Yeah, perfect. And then plus dot dot dot. And you spot on, valid for the modulus of x is less than 2/3, exactly right. And then part C is to find the coefficient of x to the 6.
then we just need to multiply minus 2. It's like minus 3, minus 4, minus 5, minus 6. Just set that 6 times. 1, 2, 3, 4, 5, 6. Okay.
Brilliant. Yeah, well done.
By 6 factorial times by 3 into x to the power of 6. That is minus 2 times. Wait, that's basically just 7 factorial. So that's 7 divided by 6 factorial, that's just 7. 7 times 3 into...
Really well spotted there, Cordelia, that you're going to just end up with 7 factorial divided by 6 factorial being just 7. Good.
7 times 3 into the power of 6. 5103 divided by 64.
Good.
X to the power of 6.
Is that your final answer?
No, it says just a coefficient, so it's 5103 and 64.
Are you sure?
Yeah.
There's something you missed off.
Oh yeah, divided by 4 was...
Why? Why divided by 4?
Because it's a quarter times by...
Good, yeah. So you've done the expansion of 1 plus 3 over 2x. 3 over 2x to the negative 2, but remember we took out that quarter, so we've got times this by a quarter.
Yeah, so... There we go. It's 5103 and 256.
Fantastic, yeah, well done. Brilliant. So that takes us to the end of our binomial theory and binomial expansion session. I hope the watchers have found it useful. Obviously you can go back and re-watch it. If you have any questions or want us to cover a different topic, then put it in the comments. Leave a like, subscribe, and make sure you signed up to the deciphers.org.
Actually, I'm pretty sure the comments are turned off.
Okay, well they can contact us on the deciphers.org, can't they?
Yeah.
Yeah. It's probably the best way for us to see it then.
And also, just contact us doesn't mean phone calls. There's this button which is request a session, so you can click that and type in whatever.
Brilliant, yeah. That's probably the best way to do it then. So let's hopefully get some people asking for particular topics to be covered. Our next session will be next Saturday, so make sure you tune in.
Yeah. So, thanks for watching, viewers.
See you next time.
Bye bye.
See you later.